Chapter 13, Metric Analysis and Data Mining. In this chapter, we'll consider details of the Google search engine, which is a data mining task. The Google search engine works with two main subtasks: finding relevant web pages and sorting them. We'll see how these subtasks are mathematically formulated and solved. This chapter shows only an example in data mining. However, the example will give you insights for solving other data mining tasks. Let's go to a general introduction to data mining. Why do we have to mine data? If we try to answer the question from commercial point of view, we can say this: lots of data is being collected and stored. Web data, e-commerce data, data for purchases at some grocery stores, and also data for bank credit card transactions. Nowadays, computers have become cheaper and more powerful. And also, the competitive pressure becomes stronger. So through data mining, useful information can be obtained, and we can provide better customized services. If we look at the task from scientific point of view, then we can say this: data are collected and stored at enormous speeds using remote sensors, telescopes, microarrays, or scientific simulations. Traditional techniques are infeasible for such raw data because it's very heterogeneous and the data amount is so huge. Data mining may help scientists in classifying and segmenting data and in hypothesis formation. Okay, here we have motivation. There is often information hidden in the data that is readily evident. So we have to find the hidden information through data mining. Human analysts may take weeks to discover useful information. Much of the data is never analyzed at all. So we have large data gap, and the data gap becomes larger and larger. The data gap means that the gap between the whole amount of data, whole data, and now analyzed data, so that the amount of the whole data becomes growing much faster than the data being used. What is data mining? Data mining is a process to turn raw data into useful information. And the task is not really trivial, and we have to use very advanced techniques and analysis so that we can get useful information. The patterns we want to find must be valid, novel, understandable, and potentially useful. Data mining is also called knowledge discovery in data, KDD. The origins of data mining, and we can draw ideas from machine learning and or pattern recognition and some statistical analysis and also database management. Traditional techniques may be unsuitable due to the enormity of data and high dimensionality of the data or variety. The data nowadays are quite heterogeneous, and here they are saved into various files and format. So we have to well organize the data mining technique from the beginning. Okay, here there are two kinds of data mining methods. One is prediction, the other one is description. Use some variables to predict unknown or the future values of other variables. That is now prediction methods. So in a sense, we try to get good forecasting, and description is find some human interpretable patterns that describe well the data. And there are data mining tasks, classification, and as in machine learning, and regression, and clustering. These are predictive, these are descriptive. And association rule discovery, and sequential pattern discovery, and deviation and anomaly detection, which is predictive model. And in this way, we have many tasks in data mining, but in big categories, we have only two different methods, prediction and description. And here we have challenges in data mining. And once we try to get useful information, then now as number of points are, as the size of the data set increases, the computational task can be much more rapidly increasing. In this case, we say that the technique, the method is not scalable. Scalability means that the computational cost is proportional to the size of data. But in many cases, the computational cost grows quadratically or cubic, so much faster increasing in computational cost, so that in many cases, the data mining task is not scalable, and which means the cost is way more expensive for large data set. Also, sometimes the data has huge dimensions, and also data can be very complex and heterogeneous, and spatially or temporally, and sometimes the data include the points and sometimes include intervals. And also sometimes the data is given in categorically, or graphic can be given, and sometimes unstructured data can be given. And also many values inside the data have some low quality, and that is because of a human mistake or the acquisition device, the quality, or sometimes people make purposely change the values to get some benefit. So data itself is not really believable in many cases. And also data ownership and distribution is an issue. And sometimes if you try to get information, and you have to also be careful around the privacy issue. Here we have related fields with data mining, machine learning and statistics, and also some visualization techniques. And also you have to use databases. And over these areas, the fields, you have to consider the techniques and manipulation to get acceptable data mining algorithm. Okay, that's the end of the section. Thank you.